Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, this is part 2. I will present to you the codes related to logistic regression. And we use the Google Collaboratory. So we move to the Google first. Okay, there you go. We have this code. I have coded this program using Google Collaboratory, so I will show to you the codes on my class. Okay, first this is the first windows, the first cell is used to import several libraries that will be used in the next stage. The first one, we use logistic regression. So this logistic regression model is already published in sklearn library. So that's why we use sklearn, and then inside the sklearn we have linear model. So open the linear model, and then inside the linear model function we have logistic regression function. And then in the sklearn library also we have datasets, and the function we need in this project is make blobs. The third one, import matplotlib to visualize the dataset, and the fourth is numpy library. And then next I will run the program, and then the second program, the second cells, we capture, we generate by ourselves. This is auto generation, makes blobs. It means we make n number of data point in two-dimensional space. For example, this one, I have n feature, so I have two-dimensional space with 3 labels or centers, and the number of sample about 1,000. So from 1,000 it will be divided into 3 categorize, and there is 2 features inside each categorize. So when we print the X, so actually the X is the input and the Y is the output. The input we have 2 features, the output only 3 labels. As you can see here, we can print the shape of input using the X, and then the shape print X, print Y to print the shape of Y, and then we got this shape. As you can see, 1,000, 2 and 1,000 for the labels. After that, we split the data sets. So we split the data sets into 2 subsets. The first one is for the training procedure, and the second one is for the testing procedure. Each subset, we have X train as the input and Y train for the output. Similarly, in the testing dataset, we have X as the input and the Y as the output. We divide 90 compared to 10. So as you can see, using this code, I just divide only from 0, only from the beginning of the array of X into array number 900. For the testing, array number 900 until the end of the array. And then we can print the shape of each subset. You can see that for the X train we have 900, for the X test we have 100. For the Y train, we have 900. For the Y test, we have 100. And then we grab the bloops. As you can see here, this is the input. The X is the input. The X have two features, which is X0 and X1. This is auto-generated by the function makes bloop. Okay, and then we have this one. How about the output? The output is the label, or we use different color to visualize the label. Here, as you can see, we have three labels or three centers. Here, this is label 1, label 2, and label 3. This is auto-generated because this is only for simulation. And then we use logistic regression model. So this one, model equals to logistic regression, and model.fit to train the model here. Okay, model fit we X, Y to train the model using training data sets, and we can predict the output using testing data subset. So the difference is using training, we only got the to train the model, and then for the evaluation, the performance of the model, we use the data subset, and we use the function model.predict, and then we just print the output. And as you can see here, the output is the X test, and for the this is the label of the output, and the prediction here, this is the output, and this is the label, and we compare the output with the label. As you can see, most of the output is similar with the label, so the accuracy should be good. And machine learning model successfully differentiate the testing subset according to the provided labels by utilizing the 90 and 10 training to testing data split. It is revealed that only few miscalculations appear in the validation results. Thus, the performance is relatively good for a small features or the low complex feature in the dataset. But for the more complex feature, for example images, maybe the logistic regression need to be replaced by the other advanced AI technology. So maybe that's it. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.